Okay, Algebra 1 fans, our topic for today, this is Notes 1-3, Properties of Numbers. After this lesson, students should be able to determine which property is represented by an expression. And before we start, let me give you your joke of the day. Why shouldn't you write with a broken pencil? Because it's pointless. Okay, so the first thing we're going to do is called spot the difference, where you can see there are three expressions here, three equations set up, and the left side and the right side are different from each other, and the question is, what is the difference? So what we want to do here is describe in words the difference between the left and the right side of each equation. How did we get from the left side to the right side? Okay, so for example here in number 1, a plus b plus c equals a plus c plus b. So it looks like the difference is here and here. Well, so how would you describe that in words? And there's more than one answer to these. But what I would say is that B and C switched, okay? That the order changed. So two ways I could write this. We switched B and C. One other way of describing it is that the order changed, because B came before C on the left side, but C was before B on the other side, okay, on the right side. Number 2, A times parentheses B times C, close parentheses, equals, open parentheses, A times B, close parentheses, times C. Now this time you'll notice that A, B, and C are in the same order, so what's the thing that changes? Well, it's what's inside the parentheses. See, here it's B and C, and here it's A and B. So what I would say for this one is that we changed the grouping. Okay, and mathematically when we're talking grouping, we're talking about parentheses here. Okay, so we changed the combination that was inside. And then the last one here, number 3, A plus B plus 0 equals A plus B, and you'll notice there's no 0 here. Now, the thing that's different is that this does not have plus 0, but if you think about it, when you add 0, you get the same thing back. You don't change the value at all. So what we did was we added 0 to get the same thing, added 0 to get the same thing on the right side, Okay, now all of these are examples of what we call properties. And what we're talking about here is properties of numbers. Okay, properties, in this case, we're going to talk about real numbers, properties of real numbers. Now these are things that are going to make a lot of sense. They're common sense because you do them all the time. You just don't actually think about the rules that you use. Properties are basically rules that when we're solving equations or when we're combining expressions and things, we use this all the time. We just don't really state what the rules are. And we're going to start with what's called commutative. There's a property of addition and there's a property of multiplication. Now, the way that I think about commutative, and I'm going to write this on the side, is that we change the order. Notice that the word commutative starts with a CO, and if I think of the word change and order, I also have CO. So what do I mean by this? Well, if I say A plus B, I can say that that is equivalent to B plus A. Now, this is how we write this with variables, but I'm also going to give an example with numbers. 2 plus 3 is the same thing as 3 plus 2. When you are adding, it doesn't matter what the order is. This is 5 and this is 5, okay? Now there's also a commutative property of multiplication. If I do A times B, that is the same thing as B times A. I change the order. As an example, if I take 4 times 5, which is 20, that is equivalent to 5 times 4, which is also 20. Okay, and again, we do this all the time, but we don't necessarily think about it. But there is a name that tells me that I'm allowed to do this, and it's called the commutative property. The next one is called associative property. Associative has the word associate in it, and when I think of association, I think of grouping. I think of things that I put together. So associative is the grouping, which in this case will be parentheses. So if I take A and I add that to the grouping of B plus C, that's the association, this property tells me that I could have associated A plus B and then added C. As an example, if I said 1 plus parentheses 2 plus 3, now that's 1 plus 5, which is 6. I could have done 1 plus 2 in parentheses plus 3. 3 plus 3 is also 6. Okay, so 6 is equal to 6. We know that that's true. So I'm just showing you that this works. There is also an associative property of multiplication. So if we take A times, I'll use the dot, and then in parentheses B times C, that is equivalent to parentheses A times B times C. Now, because we were dealing with variables, we could write this a little bit simpler. We could write it like this, and this means multiplication when variables are next to each other or next to numbers. So I could also say that's equal to the grouping AB and then times C. Okay, so if I did 2 times 3 times 4, is that the same as 2 times 3 in parentheses times 4? Well, when we do order of expressions, 3 times 4 is 12, and 2 times 12 is 24. 2 times 3 is 6, that's the parentheses, times 4 is 24. Okay, so the commutative property of addition and multiplication work. I can change the order when I'm adding or multiplying. I can also change the grouping when I'm adding or multiplying. Now, one thing, you'll notice that we don't have a commutative property of subtraction. And the reason is if I do, let's say if I do 6 minus 2, I get 4. What if I change the order 2 minus 6? Is that the same thing? And the answer is no, because that's negative 4. That's a different number. So there is no commutative property of subtraction. There is no commutative property of division, because if I take 10 divided by 5, that's 2. If I take 5 divided by 10, that's 1/2. Those are not equivalent, so there is no commutative property of division. So these are only addition and multiplication. Okay, so commutative is change the order. Associative is we change the grouping, which is the parentheses. Next one is identity. Identity, the thing that I think of, is identical, which is the same. So for addition, if I add 0 to anything, I get the same thing back. 2 plus 0 equals 2. If I multiply by, not 0, if I multiply by 1, I get the same thing back. So 5 times 1 is equal to 5. Okay, so identity is what I do, adding 0, multiplying by 1, that gives me the same thing back. Now, inverse, I am thinking of undoing something. Okay, I will sometimes say reverse the process. If I have a value, I'll actually use a number first, 3, but then I add the opposite of 3. So let's say I have $3, but then I lose $3. Well, I'm right back to where I started, which is 0. So when you add the opposites, that is called the inverse property of addition. A plus the opposite of A equals 0. Now for multiplication, it's a little different. It's A times the reciprocal, which is 1 over A, and that gives us 1. As an example, if I took 2/3 and I multiplied by the reciprocal 3 over 2, Now, if I work that out, I can multiply the numerators. 2 times 3 is 6. 3 times 2 is 6 in the bottom. And what we get is 1. 6 divided by 6 is equal to 1. Okay? So that is called the inverse. We would say subtraction and addition undo each other. And then multiplication and the fraction is like division. Those operations undo each other. Distributive property says that if I have a number a next to parentheses, and in the parentheses I have b plus c, then what happens is the a is going to multiply both of them, so it's a times b plus a times c. As an example, if I said 3 times parentheses x plus 5, that would be equal to 3x, 3 times x, plus 3 times 5, which is 15. The multiplication property of 0 says that anytime I multiply anything, any number by 0, my answer is 0. My product is 0. So that's kind of an easy one. That's a nice one. 5 times 0 is 0. 0 times 4 is 0, and so on. Now the last couple here, there's 4 more. These don't come up as much. Reflexive property, symmetric, transitive, and substitution. Reflexive is going to seem a lot like identity. Reflexive is basically things are the same. A equals A is the reflexive property. If I take the number 2, well, that's equal to 2, right? So that's a very short one where it's just the identical thing, the same thing on both sides. With identity, you add or you multiply to get the same thing. These are actually just the same, okay? Symmetric, now this one is actually useful. If A is equal to B, then B is equal to A. So this is written as an if-then statement. So if A equals B, then B equals A. So in other words, the left side and the right side, it doesn't matter which side they're on, they're the same thing. I'll tell you where you use this. When you solve an equation, and let's say you get 3 is equal to x. I know for me, when I write my answer down, I almost always write it as x equals 3. I'm used to putting the variable first. Now, this is fine, but I'm just used to doing this. I'm using the symmetric property without even knowing it. Transitive, see the word transition, which is kind of like motion, moving. If A is equal to B and B is equal to C, then what would happen, I'd say then, the first thing A equals the last thing C. If A equals B and B equals C, then A equals C. So let's say this is your height and you're the same height as a friend. And then you found out that friend had the same height as somebody else. Well, wouldn't your height also have to be the same as that other person's? That's what the transitive property says. And the last one is substitution, which is very similar. If A equals B and A is equal to C, so if A is equal to both of those, then we can say that B and C must be the same. And I'm going to tell you, it takes a little bit of practice as you look at these to kind of figure out which one's which, because some of them seem very close. And transitive and substitution are really close to each other. What I would say is that the transitive property flows a little bit better. A to B, and then B to C. Therefore, A goes to C. Where this one is A to B, but then we start at A again, A to C, then B equals C. Okay, so again, it's a little tricky. It's okay if you're a little confused. We're going to flip it on the back for part 2 and do a couple examples.